Hi everyone, welcome to 2012. We are back with an episode on HDFS, which is Hadoop Distributed File System. And to start, Nick's just going to explain a little bit about what a distributed file system is. Right? So take it away, Nick.
So a distributed file system is a little different than what someone might have on Windows or Linux usually, where all of the files are stored on a single disk, locally, literally in a box on a platter on your hard drive. In a distributed file system, you're going to store your files over multiple computers, and you might even only be storing parts of a file on a single computer. It could be on multiple boxes, spread out, replicated over this huge network. What it lets you do is it lets you store extremely large files. So I can chop up that file into pieces.
It's like how large would it
in HDFS, they use 64 megabyte blocks for actual file storage, and then by default you replicate these blocks 3 times.
Okay.
So 3 different nodes will have a copy of these blocks. What it lets you do is if one of the servers goes down or one of your nodes goes down, you still have the data because it's on 2 other nodes.
And you don't have that in a traditional...
Yeah, in a traditional file system, if you lose that disk and you haven't made, you're not doing RAID or anything like that, you've lost that data if it's not backed up or something.
Okay.
So that's how the distributed works. It's scalable, like everything in Hadoop land. You can add more computers, which lets you have more disk space. It lets you divvy up files more. If you want, you can replicate more than three blocks per node. You can just have, 5 times the replication if you're losing servers really fast for some reason. There are some downsides to doing large file storage though. The smallest size you can have is a block, so that's 64 megabytes. If you have a file smaller than that, by default it's going to take up 64 megabytes.
Okay.
So small files can be a problem. There's ways around that. You can pack them into an archive. You can take advantage of other things like HBase to store your stuff instead, which basically does that for you. HDFS also isn't POSIX.
It's what?
It's not POSIX, so you don't have random reads and writes really.
Oh.
It also, for all of its stuff, it doesn't have high availability. There's
What do you mean?
There's a single point of failure.
Oh.
So if your name node goes down, name node's in charge of keeping track of where individual blocks are going to be in individual files and what nodes have them. So if you're looking for a file, you'd ask the name node, hey, name node, where's this file? And the name node would say, oh, it's on all of these different servers, go get it. And then it's up to you to retrieve the file. If he's down, there's no one to ask, and the whole file system's down.
So
there is some way to mitigate that though.
Yeah.
There's a depreciated node called the secondary name node that used to be used with earlier versions of Hadoop. Now it's transitioned into 2 other type of nodes called the checkpoint node and the backup node. The backup node can actually function as a name node server because the backup node itself actually stores a replica of the log and the image in memory. So you can just spin up the name node service. I can't think of what it's called at the top of my head, but a backup node can be a name node. With the checkpoint node, it's a little bit different. It's just taking checkpoints like the old secondary name node did of the log and of the image in memory. So you would have to spin up another node to actually act as the name node and then copy that information back over. There probably is some downtime. I mean, I don't think there's any automated way for the backup node just to kick in and say, hey, I'm the new name node. Yeah. So yeah, there is going to be some cutover. Someone has to actually physically do it. So you have to be monitoring it. It'd be nice in the future if maybe there was some sort of high availability, some sort of heartbeat between the 2.
Yeah, I know it's being worked on. I can't remember the specific project, but it is still a single point of failure, unfortunately.
So that's, I mean, you guys have touched on a lot of the things in like all the parts of HDFS, but do you want to just like quick give an overview of the architecture?
Yeah, so we talked about two nodes. The name node is really going to be your master node. That's what the clients communicate with to determine what other data nodes, which is the other type of node, are available. Your data nodes are your nodes where your data is going to be stored. It's the name of the node. So, and those are your worker nodes. Those are the nodes that the clients are actually going to write data to, and those also are the nodes that your job tasker, job tracker jobs on for MapReduce. So you're going to have one name node, and the rest of your cluster is going to be data nodes, and that's kind of a high-level architecture of how it works. And like Nick was saying, with replication, that everything gets replicated 3 times by default, and to 3 different data nodes.
But the metadata is stored in the name node?
Yeah.
Okay.
Yeah. One other piece of the architecture too is the client, who's actually going to be making jobs for people to do and transferring files. You don't transfer files through the name node. You say, where do they go, or where do I get the files from? And then it's the client's job to actually transfer the files directly to a data node, and they kind of live outside of the cluster usually.
In terms of security, I know that Nick, you were saying they just released the newest release of Hadoop 1.0, and it has increased security. They fixed a lot of the security issues, but you were saying there's still some that remain to be fixed.
Yeah, Trend Micro started a security enhanced version of Hadoop a few years ago, I think. I'm not sure on the dates. It's been coming along pretty well. I thought all of the Jira issues were going to be in the 1.0 release. It looks like there's a few that didn't make it and have been punted to the next one. But security has come a long way in it. It's going to be pretty much Kerberos enabled. HBase 2 in the very short term, if it isn't already in some bleeding edge branch. I haven't checked today. For all I know, they could all be closed.
Okay. So, but in terms of like comparing it to a traditional file system, is it still much less secure?
Yeah. Compared to a traditional file system, they've got 30 years, 40 years of doing permissions and authentication.
Right.
So the authentication model you have with Hadoop and HBase just isn't there until this sort of stuff is done. Basically, you're back to old-fashioned usernames and passwords, and you're in. Or in a lot of cases, there's no security at all on the cluster, and you're getting onto the cluster through a gateway that's doing all this on the cluster's behalf, using traditional methods, like a proxy.
I think we missed on one key point of the architecture too. HDFS and Hadoop as a whole typically run on the Linux platform, even though they're Java based, and they're ready for production on Linux. I shouldn't say they won't run on Windows. It's recommended that they don't run on Windows yet because it's not quite ready. And I believe the spin-off Hortonworks from Yahoo is actually the one who's trying to port it onto Windows. And that's probably going to be key.
I think they're bringing it out to Azure.
Yeah, Azure actually has a CTP review of Hadoop on Azure and with their Metro interface.
Okay. All right. Well, I think that's all we have time for today. But we will see you next week with more big data.
More data, more problems.
More data, more problems. All right. Bye, guys.
Bye.
See ya.